So welcome. Thank you for joining. I don't know if this is your first or fifth, but this is week 5 of our 8-week free webinar educational series from KOW Building Consultants. I'm Ken Willey, President and CEO of KOW Building Consultants, and I'm going to be taking you through over the next hour or so, not more than, a topic that I actually think is really, I actually think it's pretty fascinating and not really all that discussed. It's not all that covered when it comes to what it is we're looking at, how we're looking at it, and what to do next. And really it's regarding one thing, and that is old New York City specific apartment buildings. A lot of what I'm going to say applies to our older cities in this country, like Boston and Philly and other cities as well, Chicago, but I'm going to be very New York City specific and centric, but I think that everything really can go from not just New York City, but throughout and apply to different areas. So we're going to talk about a residential renovation project from concept to completion. So before I dive in, I always like to just give a little bit of, in my opinion, when I write these webinars, and this webinar, by the way, will be up on YouTube later today or tomorrow for free viewing for yourself, a peer, a colleague, whatever you'd like to forward to them. Just go to YouTube, go to KOW Building Consultants, go to our page, and on our YouTube page is several things. The 8-week webinar series is there, and you'll see this one later today or tomorrow. So my question is going to be, okay, what is the question I'm looking to answer today? What is the goal for today? Here's today's goal. Here's today's goal. Let's say you're working at a bank. Let's say you're a newer employee. Doesn't really matter, but let's say you are. And let's say we meet out in the field to go look at some buildings that are going to be renovated. They're going to get a light, moderate, or gut renovation. And you turn around to us and say, what should I be looking for? What's different about a renovation versus a ground-up new construction? There's some obvious ones. For renovation, we're not going to probably have to build a whole new foundation system. But there's a lot of things that I hope after today, we could put the pieces together. And one of the things I'll say before I dive into this is I tell my kids, they're 16 and 13, my son Carrick and Annabelle, I say, what you'll find is the more you learn about something, anything, the more you connect dots. And that's called experience. That's called wisdom. So I'm hoping today we can take those dots and fast track it and put them together so you stand back and go, oh, that makes a little more sense now. So that's the goal of today. A lot of photos, little history, then we'll dive into the photos. KOW Building Consultants, we're a consulting firm based in New York. We cover much of the eastern part of the United States, as well as we have an office in Denver, doing construction consulting, owner rep, and building inspection services. If anyone would like more info, kowbc.com is our website. Everything is on there. If you'd like more information, please go and take a look. Let us know where the lights are on, even though we're working from home. So let's just go through a little bit of a history, which I think puts in context what we see today. And I think I'm a civil engineer, that's what I have my PE in. I think that the old building stock in New York City is one of the most cool and interesting aspects of real estate in New York City. So a quick bullet point history we'll walk through. So first of all, going way back, by the end of the Civil War, the Manhattan population hits about 1 million people with about 15,000 tenement buildings. We're going to get into that in a second. And at this point, New York City was Manhattan. Brooklyn was its own city. They had not combined the 5 boroughs yet. So by 1865, the end of the Civil War, a study showed that 65% of the city population were living in substandard conditions. It was a problem. It was a problem from a hygiene standpoint, from a health standpoint, and this was something that the city knew they had to address. So the Tenement House Act of 1867 required fire escapes and windows in each room. Fire escapes to give you a second means of egress or exit if you have a fire at the one door, and windows in each room to give you light and air, ventilation. So that was 1867. There were more reforms, 1879, 1901, and 1919. And if you want to geek out, you can certainly Google and geek out on all this. A lot of this I found on New York City Library System, which is terrific online information. But you can obviously Google this to your heart's content. By 1870, okay, now we're after Civil War, French flats have been introduced for the middle class, which was an upgrade from old tenement buildings. And again, we're going to go through kind of that definition of tenement buildings in a minute. By 1900, half of the middle class in New York City, in Manhattan, lived in multiple dwelling units. 1901, law changes, allowing buildings to rise twice the width of the street. So zoning starting to come into effect. There's a building in downtown Manhattan that went straight up, the equitable building, and it put a lot of shade on things, and people kind of freaked out a little. And they said, you know, maybe we should come up with some zoning laws on setbacks to allow air and light in. So these things evolved over time. Nothing happened all at once. 1904, mass transit, subway system. It helps push larger multiple dwelling units. People are more mobile. Elevators help the restriction of a 6-story or lower building. A lot of people think it was only elevators. It wasn't. It was really 3 things. Why did we stop at 5 or 6 stories for most of these old buildings? Number 1, elevators. 2, it's just physically what people were willing to walk up and down as a daily getting out of the building and back home. But it was also by the firefighters' access, ladders. If the ladder could reach you, the ladder could reach you. If it couldn't, that's a different story. So a lot of it was dictated by that. I mean, we still see some cities and towns, older developed areas outside of New York City, in the suburbs and all, where, you know, there's certain streets that the street is so old and so narrow that the firefighter's truck is a different type because it has to be able to make turns. So, you know, these things dictated not only how and where we built, but how tall we built. 1929, multiple dwelling law. Okay, by this point, almost all upper and middle class residents in Manhattan were in apartments. Multiple dwelling law put into some safety features regarding how and where we built and occupied apartments. And then, of course, we have a boom of apartment buildings, which really started after 1900 and continued to World War II. A lot of the buildings we see today that are those old code tenement, again, we're going to cover that, is those 1910, 1918, 1925, 1930. Those buildings, there was a boom of those buildings built up to World War II. And obviously, anytime says pre-war, this is the period they're talking about. It's interesting, from 1930s to 1960s, there's actually a policy in the city of what they called slum clearance. So they were looking to take a lot of those old, small, unsafe, unhealthy buildings, many of which were in structural disrepair and were a real concern, and they called it slum clearance to replace it with a better, proper apartment house. So that was a policy that was in place for 3 or 4 decades. So a couple other notes until we dive into some photos. Prior to 1938, buildings did not need a certificate of occupancy in New York City. You could have gotten it, but you didn't need it. It wasn't required. Part of the reason why, and Tim Lynch from the building department did a great seminar on this a few years ago at Live Safe, Build Safe. Buildings were built out of a pattern book. So you'd look at this pattern book, select this building that you'd like to build with your husband or wife or family or whomever on your lot, and that's the building that the builder would build. They didn't deem a certificate of occupancy necessary because the builder built the book pattern, the design that was in the pattern book, which is very different from today. We still do a lot of checks and balances for a CO, but the thinking back then was, and I actually saw literature written about this, if you selected a building out of a pattern book, what do you need to check? Just build that, and that's what they did. Now, prior to 1938, if you're doing any renovation or work out there and you're curious and you say, well, if I can't get a certificate of occupancy, is there anything else I can get? Yes, you can get what was called a green card. And the green card is on HPD's website, and it's also called an I card or identification card. And it was an accounting of who was living at the different homes or apartments or buildings prior to COs. So it was really like a census count as far as accounting for people. But because of it, it'll have a sketch of the building, it'll have dimensions. So you can find these on HPD's website for free. If you go on there and look for iCards, and you can find these cards, which are considered a legal proof today of what that building was built at prior to a CO requirement. So a lot of this can be summed up as follows. When we say pre-World War II or pre-war, we're generally talking about tenement buildings which were built for working class families. These are buildings that have generally wood joists, bearing or sitting on multiple layers or wipes of brick bearing walls. We're going to see lots of photos in a minute, and rubble stone foundations with spread footings. That's traditionally what we're going to see when we say pre-war. Keep in mind how code has changed over time. Obviously, code has changed considerably over time, and it's not done changing. It's always evolving and changing to meet needs. And I mean, if you look at what's going on today with COVID-19, I guess even the riots, but certainly COVID-19, that might have an impact on building code. It may have an impact on how we are allowed to build office spaces or light and air requirements. So these things change over time. Generally speaking, your rehab, your renovation doesn't need to meet the current code with some exceptions. So you start doing this renovation, you say, well, what do I have to meet for new code? Typically, some energy efficiency items like R values, light and air requirements, electrical, fire sprinkler, but that existing building could stay where it is for the most part and be what we call, it's a long way of saying grandfathered, pre-existing legally non-conforming. You grandfathered in. You don't have to change it. I'll give you an example or kind of a corollary. Office buildings. In New York City, for a long time, there were a lot of office buildings that did not have fire sprinkler coverage, and they were fine. They could do some work, they could replace a boiler, they could do a new roof, and they did not have to put in fire sprinkler coverage. That is a true story. They were legally non-conforming. And then the city said, you know what, not so fast. Let's require this and give people until 2020 to do it. So buildings over 10 stories that are office buildings, you're no longer grandfathered in if you have fire sprinkler coverage. So that's a difference of where the city said, we're okay with some things, but some things we're going to make you do even if you weren't going to do a renovation. And a lot of times what will happen is the heavier renovation you do, this is really anywhere, but certainly in the city, more things will kick in that are required. Another thing that we're going to see some photos and talk about is one of the most genius things, in my opinion, of the design of the old tenement buildings is that the front wall would go from side lot line to side lot line, and so would the rear wall. But in the middle of the building, they'd bring the sides of the buildings in and then back out and create that air and light shaft for bathroom and kitchen windows, which was pretty genius in my opinion. So these tenement buildings were built for renters. They were built for working class families. Usually a couple kids, whatever it might be, that's who the tenement building was built for. Brownstones, completely different. They were built typically for an upscale single family. We'll see some photos on that in a minute. Very different design, very different layout. And I mention this because if you were to say to an unsavvy person, tell me about this building, and they'd say, I don't know, this is a 100-year-old building that I'm looking at, an apartment building in New York City. But if you see a brownstone and a tenement, think differently. They were different original intended uses, different layouts, different in many, many ways. A lot of this likens back to those tenement buildings where you had what was called the Manhattan grid, 25 feet by 100-foot lot. So you had 25 feet across your front and back, 100 feet depth from the front to the rear line. And then the tenements often would be occupying 90%. One of the tenement styles, which we hear a lot, is called railroad or shotgun or floor through. Those are all the same thing. What is railroad style? Basically, think of it like you walk into a hallway and you walk down the hallway and there's various rooms and kitchen and bathroom that you're feeding to, and that's your apartment. So you're moving down the hallway and each room feeds off of that. Very common, not in all of them, very common in tenement buildings. So let's compare a couple building types, then we'll really get into the tenement. So here's a building, 4-story, I'm assuming walk-up, retail first floor, old brick facade, stone above windows and below windows and sills, a cornice at the top, smaller style, mixed use. 7-story, some decorative stone, a little bigger building. Looks like we have a main entry where they have a ramp there, probably was added after original construction. You know, our handicap accessibility for our old buildings was very, very poor. Our handicap accessibility for our new buildings is very, very good. And it varies in between on when you did a renovation. You have these Juliet balconies. They're balconies you can kind of step out onto, not really. It's a Juliet balcony, nice looking facade. Good classic 6-story brick tenement style building, flat roof. Looks like they have a sidewalk shed up, starting to do some work. We see our fire escapes out front, our second means of egress. Most of the time, that second means of egress, those 2 windows will connect 2 different bedrooms and supply that second means for that apartment. And then the first means or the primary means would be the apartment entry door. However, you do see some buildings still to this day that have 2 apartment entry doors from the hallway, and that's their second means. Now, by the way, if you're thinking to yourself, wait a minute, if I can go out on a 4th floor fire escape and walk down to the sidewalk and escape a fire, why don't they have fire escapes at 25-story buildings? Well, one, we really don't want people walking down 25 floors fire escapes for a lot of reasons. And 2, those structures are typically fire rated, non-combustible construction, fire sprinkler, fire alarm, and have much different life safety programs in place from a fire sprinkler, fire alarm, and emergency lighting, so that you don't need to walk all the way down. And most of the time, they'll tell the residents, stay in your apartment, unless we're told, walk down the stairs and move out of the building in one of the multiple stairwells. Good 6-story tenement building, fire escape at the front. Looks like it's got a newer building to the side. I don't know what kind of that, if that's a residential or what have you. Pretty good looking building, cornice up top, kind of classic style. And you know, a lot of these buildings, like I can look at the brick and usually guess within 10 years which it is. Just I've learned from architects and engineers and inspectors over the years, hey, you see this brick? Yeah, this is an iron speckled brick. Anytime you see that tan brick with like that charcoal looking dots in it, that's iron speckled brick, very popular in the 30s, you know. So the type of brick they use actually did vary, but the same function of keeping elements out, supporting the structure were the same. Great, good old 5-story, looks like it's next to a firehouse, which is nice. You know, each one of these is a different building. You're looking at 4 different buildings there, and they're all cookie cutter. They're all kind of the same. Good looking block of the same building type, age, layout, etc. Brownstone. So when brownstones were in their popularity, and many of them were built for upscale single families, a lot of times downstairs in that English basement or that door you see downstairs, that would be where a maid, a butler, servants' quarters would be for them to live. And a lot of times you'd actually have 2 kitchens. You'd have kind of the main kitchen down there. Sometimes they'd have their own kitchen, but the point is it was a single family home, great quality of construction, good builders were used on this. And believe it or not, brownstone was actually a cheaper alternative back when it was built. It was stone that came down from Maine and New England on the Hudson River. Now it's very expensive. But you know, a restored brownstone building, I mean, there's nobody that doesn't like that. It's just a beautiful, rich looking building, and you know, it's just a classic New York City looking type building, one of the types. All right, so hey, you know, Led Zeppelin, Physical Graffiti, the album cover, tenement building, boom. So I was kind of thinking about this. I was talking to my kids about it over the weekend. I'm like, I should probably show like a pop culture reference. So I was going to show you a picture of Friends, but let's be honest. You'd rather have Led Zeppelin. You know, which do you want to take a picture in front of? 9 Meets 8 Marks, where the physical graffiti is, or where Friends building? Exactly. And if you don't know who Led Zeppelin is, shame on you. Google it. Go check it out. All right. So we kind of looked a little bit about our history trail and outside what they look like. But let's get into the details. What is different for an old building? Now, this is not an exhaustive list, but this is as good a list as I can come up with asking a handful of inspectors as well. Stuff you don't see anymore. Different stuff. And different stuff means if we walk in before the renovation happens, we're going to have to think about and consider, is that an issue? Is that something that needs to be cost or figured out? So let's go through what is different from a new built building and a lot of these older tenement buildings. First of all, new building, poured in place concrete foundation. The walls that support your first floor and above that you see from the cellar are poured concrete. Old world building, brick or rubble stone foundation. Rubble stone is literally just stone with some grout, some glue, and that's what transferred the load to the earth. Is it bad? No, it's actually terrific. Some of these 120-year-old buildings haven't moved an inch, and they're going to last another 120 years. They were structurally very, very well built. The foundation system. We'll get into some of the things above the foundation system. Plaster and lath walls. Now, you can kind of see in the top of that electric box what that is. So, post 1960s, we have sheetrock, which is a wonderful material. It's a gypsum-based wallboard that goes up to studs. Before that, they had to build their own walls. So they put those laths or pieces of wood, and then what would adhere to that would be the plaster. And then when that would dry after a few coats, you had a smooth finish wall. So that's a very typical characteristic. Actually, it's a guaranteed characteristic of your old tenement buildings. Hardwood flooring. You see a lot of hardwood flooring, original. Great stuff. Kitchens, baths, and near your radiators, you're probably going to have an issue because it's been wet, and wood and wet don't do well together. Other than that, you're going to probably have some deflection in your joists, but your hardwood flooring is solid as can be. This was great, great wood back in the day. This was natural forest wood, not farmed wood. And if it's in good shape, you can patch, sand, poly, and bring that thing back to life, and it looks gorgeous. A lot of times, I don't have a picture on this, a lot of times what they would have done is around the perimeter of the room, if you ever see it where it's a darker wood, that little trim piece, that, again, it looks fantastic. That's walnut. And hardwood flooring comes back to life. Now, you can't keep sanding and polying because eventually you lose too much volume, you got to replace. But you'd be surprised. You can go in 80, 100-year-old buildings that have never had a big reno job, and most of the flooring could look in really good shape. Dumb waiters. You still see these. Now, you're looking in someone's kitchen. And by the way, this is a very recent photo I took. These are still very much around. What's a dumbwaiter? Dumbwaiter is a small elevator that you pass food, laundry, etc. up and down from the cellar to the other levels of the building. So the workers could pass the food up, the dishes down, the laundry down, the clothes up, and it was basically a non-human elevator with a pulley system. Whenever we see these, the question is always, what are we going to do? Are we going to remove them? Most of the time, they'll leave them. And if you can imagine, this is open all the way as a shaft. Obviously, it's open because you've got this pulley system, this elevator that's moving stuff up and down. If we install a floor at each floor, you convert it into a closet in the kitchen. Very often, that's what's happened. They convert it into closets. But you still see a lot of dumbwaiters. Icebox. This one's a little hard to see. I apologize. I didn't know I was going to be using this, and I was going through old photos and I found it. If you see that thing in the corner there, that's an icebox. This is pre-refrigeration. That was at the window in the kitchen. It has a metallic icebox, and it used to have a door. We even see the doors sometimes. and you'd literally put ice. The Iceman would come by in a cart with a horse, and you'd buy ice, and you'd put ice in there with whatever you wanted to keep cold, your milk, your eggs, your meat. Still see ice boxes. Now, when I see an ice box, from our standpoint, I think, okay, are we going to use it or are we not going to use it? Do we have to insulate it? Is it leaking? But you still see these components. You still see, whenever you hear ice box, or if you've ever watched, the Honeymooners, that's an ice box. Built-in kitchen cabinets. This is one that's interesting. Sometimes, a lot of times actually, or I want to say always, they didn't order cabinets from a company. They built them in place, which does two things. One, they're really good. They're usually in really good condition. They're strong, they're structural, they're literally built into the kitchen. The bad news is they're tougher to remove. But you do see a lot of built-in cabinetry. That's just how they did cabinetry back in the day. You didn't go to Lowe's and buy a size and figure it out on the site, or order it, which we do today. It was built in or on site. Gas meters in kitchen. See this a lot. You go up in the kitchen, you look up above, usually it's above, sometimes it's below. That's where the gas meter is. Question to ask, aha, are we going to be moving these gas meters down to the cellar? 10 times out of 10, yes, we are. We don't want anyone to have to come into the apartment to read the gas meter. It's better for everyone. We'll relocate these down to the cellar. Is it a big project? Not if you're doing a mass renovation. But yeah, it would be. It's not an easy thing to do. But again, you see it, you know it's going to be part of the renovation. Bathtub and kitchen. Still see that. So you go in, you see this bathtub in the kitchen. I think the reason was, I never looked into this, but I think it was that you could heat water and pour it right into the bathtub, and then each member of the family could take a bath. The baby's last, which is where the don't leave the baby, throw the baby out with the bathwater term comes from. You still see bathtubs in the kitchen. These still exist. This sucker probably gets $3,500 in Manhattan a month, but you still see it. Bathtub in the kitchen. You have a toilet room, but this is where the bathtub is. Gas lighting. Pre-electric lights. This had gas. You could see at the bottom left there where you turn it on and off. Gas would come in here. You'd light it. There's your lighting. So this is obviously going to be dead. No one's using this. It's going to be removed. Not as a safety factor as far as it's filled with gas. We hope it's not. But just, it's obviously a very outdated item. Small bathrooms. This is a killer. This is a really tough one for renovations. I mean, if you look at that clearance right now, between that wall and that tub, you maybe have 16 inches, maybe. That's a really, really tough bathroom to negotiate. They just did not build big bathrooms back in the day. Forget about a 5-foot radius handicap accessible space. So these are tough. These are tough to deal with. We'll usually have to see the architect come up with a clever idea of how to take some space from another room, redesign the bathroom, and put the tub against the wall or something, because this won't work. This is just not going to fly with this limited clearance. No GFI. See that a lot in bathrooms. There's an outlet. That's got to be ground fault circuit interrupter protected. It's not. That's an easy fix, but again, it's very common for a lot of these old buildings. How about this one? Where's the outlet? There is none. We still see a lot of bathrooms that have never had a substantial renovation, and there's no outlet in the bathroom. There's a light and a switch, and that's it. Now, you could replace the light with one that has a plug-in, which is really not a good idea in a bathroom. You're not supposed to do that. But you actually have a bathroom without an outlet. So what do we do with the renovation? We'll install one, but it's not even a matter of it's not GFI rated. You literally don't have one. And you see that a lot for a lot of the old buildings if they've never had a renovation. And look at the sink, you could see they have hot and cold. They don't have one tap. They have hot and cold. It's funny, I worked, my first job in high school, I worked in like a meat market, like a food shop. and they had one of these old sinks, and it took me probably a good month before I said, oh, I get it. You fill it with cold, then you go over to hot until you get your temperature. You know, I'd never seen that before, but you know, you still see that a lot. You've got the hot and the cold tap. Old ballast window. So forget about the idea of energy efficiency, or forget the idea of double pane windows that give you an air white, thermal break, lowy. You've sometimes got these old windows that have these chains and ballasts and weights. Believe it or not, if they've been maintained, they could still work great. I've seen very heavy windows that have weights and a ballast system, and you can open them easily, but they're not energy efficient, and you are probably going to have to do a replacement. Obviously, you're going to have to consider, am I landmark protected, etc., but you're probably going to have to do a replacement. You also have weatherization type windows. So maybe the building has never had a substantial renovation, but we did a weatherization window replacement 20 years ago. A lot of times those windows do not last very long. A typical window should get you 30 years. Those type don't. Those type might get you 15 years. They're starting to fail. Gaskets are starting to go. You're starting to get condensation between panes. That window's failing. That window's failing. Fireplace. Still see a lot of them. Not used, but they're still there. Kind of a nice character piece. Original apartment entry door. That apartment entry door I saw last week, I am not kidding you, and that thing is from 1898. That's what they had at the apartments. Is it fire rated? Does it work? Is it proper? We're going to do reno, they're going to replace them. Although it has a lot of character and style, old doors, old moldings, old hardware, you'd be amazed how much of this you still see original in a 120-year-old, 80-year-old building that's still there. Sure, they may have replaced the refrigerator, they may have replaced the cabinets, but you're going to have original doors and hardware. Believe it or not, you still see a lot of it. Leaking skylights. Anytime you see a skylight in one of these old buildings, your bulkhead is getting hit from all sides with air, snow, sun, rain, sleet, wind. There's going to be leaking skylights. Telltale sign, all these buildings, you're going to have to do a skylight and bulkhead restoration. Flat roof, very common element in a lot of these buildings. You notice you don't see a lot on that roof. You don't see fans for the bathrooms and kitchens. You don't see fans for makeup air for the corridors. You don't see cooling equipment. You don't see elevator bulkhead. Very common. Not a lot going on in the roof in a lot of these old buildings because we have very little mechanical equipment. Old bulkhead, which is anything that goes above the roof, like a stair bulkhead, an elevator bulkhead. I know, like, if you watch Homes on Homes or in Canada, they call bulkhead kind of the things above you that run chases and ductwork and such. That's a stair bulkhead. That's a chimney. Old bulkheads, skylight, water infiltration, probably going to be an issue. What else is common in these buildings? Brick issues, usually at the parapet. And the parapet wall is the wall above the roof. So it's getting hit on three sides: the outside, the inside from the roof, and the top. Brick issues the parapets. You could see on this building, they had to replace a lot of the brick above the roof line. And on this building, they're going to need to. So your brick issues, most often you're going to see them above the roof line at your parapets. No backflow preventer in water systems. That's going to have to be installed as a safety device so you don't get a reverse siphon and send a contaminated water back into the potable system. Old coal chute. You see these a lot in cellars. So pre-gas, pre-oil, you'd have a cart pull up with coal. They'd shovel it down here, it would slide down the coal chute, and then you put the coal into your boiler. That's how you make your heat. Most often heating system we see, Scotch Marine steam boiler with heating coil. Sounds like a lot. Let's break it down. Scotch Marine, these are old steamship boilers that made their way into buildings. And it's a tubular or a Scotch marine boiler because that's where they originate from, which is why the word marine is in it. Steam, meaning that this takes water and produces steam. Steam rises, goes up through the building, there you go, you got your heat. But not so fast. We take that same heat we've produced and that same steam, and we send that steam out in these two pipes at the top, cool it down a little bit, and make it hot water for sinks and showers. So this one unit provides heat and hot water. Very common in a lot of these buildings. There's nothing wrong with the steam system. There's nothing wrong. This is an AL Eastman, great boiler company. Nothing wrong with it. But we're going to probably have some questions on how we can make things more efficient. And if you asked our sustainability team, we're not fans of just rip it out. We're probably going to say let's leave it, but let's be a little smarter with controls, with windows. Let's make an efficient building, but steam heat is actually not a bad system, even in today's age. One pipe steam, most common in these buildings. If you look at the bottom right, next to that outlet, which is kind of ironic, the steam comes up because steam wants to rise because it's lighter than air. It goes into this radiator. It gives you the nice heat. It cools. It turns to water. It drops because it's heavier than air, and it goes right down the same pipe and passes the steam on its way. If you're thinking, wait a minute, it doesn't seem like a great idea to have cold water pass steam because it's going to take away some of the heat, bingo. Two-pipe system would send steam up one way, water down the other. But this is what we see most often. Much simpler system that they installed basically across the board for these old tenement buildings. Sometimes for rooms, you don't even have the radiator. You just have this riser. That's your heat. Bathrooms is a perfect example. Kitchens is another. They didn't even give you heat in those rooms. They just gave you this guy, and it would let off enough waste heat that you'd be warm. No ventilation, no cooling, window units. I think everyone already knew that one. One of the common problems we see, Federal Pacific stab lock breaker switches. This is, if you're curious, just go ahead and Google that. It was a defaulted product. It would not trip when it should trip at overload conditions. There was a class action lawsuit. They're now out of business. They lost, and it is a potential fire hazard. When we see these, it's very simple, replace. We still see a lot of them. A lot of them were installed in the 80s and 90s. We still see a lot of them. We also see fuses. Replace them. Replace them. There was a time even in my career where it was okay to keep them, and we put in these tamper-proof inserts so you could only put the proper amperage in, so you wouldn't fool it into not tripping. But now we know that it's got to be at least a certain number of years old to be a fuse box. Replace it with breaker switches. All right. So we looked at a little history. We looked at a little building type. We looked at how the units are different. All right, now we want to start work. So once we've started work, how is it different than new construction? What's a different consideration? First of all, demo. Demolition is the most dangerous part of the entire job. Very, very sensitive. You're removing a lot of load from a building. You don't know exactly what's going to be uncovered in the building. The building could move, shift. It's breathing and it's a very, very sensitive time to do the work. So doing demolition is something that has to be done by just contractors that are so trained and licensed. Like this site right here, this is a very dicey time for the project. I would hope that the structural engineer did their homework and a big wind gust is not going to knock one of those walls over. But you notice that they made them keep those cross braces in while the demolition is going on. But the reason I like this photo is because if you look at those pockets, the little holes along the left side and the right side of the photo, those are the joist pockets. That's what the joist sits in and spans across, creating each floor. So you're seeing it removed in what it would have looked like before they even built those floor systems. Actually, they wouldn't have built it in that order, but the point is, it's a good view with the joist removed of what the structure looks like. Plaster and lath ceiling. A lot of times we're doing demo. Demo joists are going to be cut. They're going to be notched. Again, sensitive time of the project. Here's brick. See, this is a brick building. Brick on the outside, brick on the inside, brick, brick, brick. That's what's supporting wood. We don't really do this anymore. But a lot of those buildings are so over-designed structurally, they're just fine, and they will be fine. The brick's not usually what fails. It's the joist. And it's a joist because the joist gets wet or fire damage. Not a big fan of piling up materials during demo. I think I said something right after I took this photo. But again, dicey time of the project. Very dangerous. Be careful. You can only have one crew working in there right now, demo, or a demo/structural crew, because you might be doing structural work at the same time you're doing demo work. You can't just remove everything. You might have to do some structural work to fortify the building while you're doing the removals. Here's another view of removals. Starting to see some new structural steel go in. New stairs around the core where the elevator shaft is going to be. Starting to take form. Old plaster and lath, doing some more demo. Now, as we start to add, okay, let's say we got demo done. Let's say, for argument's sake, we're ready to do new construction. Now what? Well, here's one consideration you don't have to worry about on new construction. How the heck am I going to get this stuff in the building? I got a building in the way. I can't just drop material from the sky, from a crane or a boom or a lull. So getting material into the building is actually a consideration that you don't have to worry about on new construction. But you see here, they're going to dicey, it's tough. They're going to bring it into one of the windows. Unfortunately, while we're building this building, the building's in the way. That's a consideration. It goes a little slower because of it. We have these joist pockets. They're ready to receive new joists. Some of them get filled in. When they get filled in, we could add this steel piece below. The joists are now going to go on that. Structurally, that was the way the structural engineer wanted to go. Looks like a good system. Another kind of structure we see out there, brick arch. You see a lot of this down in the first floor, where they wanted to create a fire-rated, hardy construction of the first floor. So I'm down in the cellar looking at the first floor. You've got steel purlins running in and out of the photo, and then the brick arch you see between. An arch is a wonderful, wonderful discovery we made in nature of a great structural shape, because as you load it, it gets stronger. So this is a brick arch system. In fact, I've seen buildings where they would use the steel purlins would be built the width of a beer barrel, and they would use a beer barrel cut in half to set the brick and the arch. Like, you see, there's a lot in Brooklyn. This is pre-refrigeration, so your beer had to come from a local person or you weren't getting it. And you'd see that the purlins would be the width of a beer barrel, or diameter of a beer barrel, sorry. All right, starting to see some joists. Excellent. Starting to look like a building again. We're going to leave some of our joists. We're going to sister some of our joists, which means put one next to. We're going to build up on some of our joists. Again, every job's different. Every area is different. We don't know until we remove things. And the architect and structural engineer will say, here's the best path forward. We made assumptions, but we just don't know until we get in there. Dust protection, very important on demo jobs. The worst areas structurally, bathrooms and kitchens. Bathrooms and kitchens are going to see the most water damage, the most structural damage. You're going to pretty much assume you're going to have to do a lot of joist and structural work there. Bedrooms, living rooms, dining rooms, not so much usually. You're going to see a lot of temporary structures be built. Again, we don't need to do this on new construction. We're just building. Temporary structures, structural engineer, architects say, yes, that's adequate to support that while we're replacing pieces. We're going to look at the condition of the rubble stone foundation wall. Is it in good shape? Do we need to parge it or patch it with grout or mortar? Ah, nice new joist. Got a joist anchor slushed in with the masonry. And you see, we're starting to see metal framing. Now it's really starting to look good. Now we're really starting to see things get added and not taken away. In this job, they put steel joists. Whether they put wood joists or steel joists depends on the structure, the code, and what we're building to. Remember that fireplace? I'm not a big fan of fireplaces structurally. You know why? Because if you go straight up from a fireplace, which is where the smoke wants to go, it's hollow, which means structurally, we're going to have to build around it above to make sure our joists above are picked up properly. When I see fireplace, I think voids. And that's what you have in the wall. It's a void. Obviously, it's a void. It's where the smoke had to go up. What kind of exteriors do we have? Well, a lot of times we'll have a brick where we cover with thorough coat. Very common on side, light air shaft, and rear facades. It's a good cementitious coating over a brick. Good application. Here's a brick, old brick building. Cornices, a lot of times they're in damaged shape, they're in disrepair. If we can repair them, we can. Otherwise, we'll replace with a fiberglass cornice. Fiberglass will be easier and cheaper than replacing original, whether it's metal, stone, etc. And fiberglass will be the way to go. How about building entry? You know, if it's a renovation, we're probably going to have to deal with what we have. Not going to get into a whole handicap accessibility here, but a lot of the steps and stoops of New York City, although when repaired, really give a lot of charm, they're not terribly efficient for accessibility. Here's a view of some brickwork that's going to be needed and facade work. And the bulkhead again. All right, here are my final parting comments, because everyone always says, well, which is better? Well, forget if you're an old school style kind of person, if you're a new school Scott. Let's just go through some pros and cons. So why is a renovation better? First of all, it's faster. I don't have to build a foundation. I don't have to dig and worry about that guy's building and this person's building, her building. Faster as far as time is concerned. Yeah, demo takes some time. That's true. But I'm building on an existing foundation that's going to save me time. Sometimes we have higher ceilings. Not always. Sometimes. Sometimes we have detailed woodwork, fireplace, pocket doors, things that give it charm. I've seen enormously big and heavy pocket doors that roll with a finger because they're just built so well and they're so true and they just slide in a beautiful way. So if you want to bring that work back, you really can't replicate that with new. It's gorgeous when you do. That woodwork, that coffered ceiling, that crown molding, beautiful stuff to help the look and the aesthetic if that's what you want in your building. Hardy wood, really strong wood. The wood that they built back in the day was a 50, 100-year-old tree. The wood you use today is a 20-year-old farmed tree. That stuff beats our stuff hands down. As long as it's not damaged from fire and water, or you didn't cut the hell out of it to run electrical and low voltage and ducting, hardy wood, great stuff. Lasts a long time if you've taken care of it. Beautiful facade. I mean, a beautifully restored old building, you can't beat it. Just beautiful up front. A lot of ornamental members and dentils and above the windows, and you know that look is something that's just classic, and I don't think that's ever going to go out of style. Structurally sound. I mean the building itself. I don't mean the floors. The building itself, the foundation itself. These things aren't going anywhere. I mean, I've seen literally 120-year-old buildings that haven't, I don't see a crack down in the foundation. You could land a helicopter on 2 of them on the roof. Now, I'm not talking about within the building. I'm saying the structure itself. They are built very robust. It takes advantage of lot lines. If I got one that's got a front line, a real small rear yard, and 2 side lot lines that are full, I maybe can't do that with a new building, but I'm grandfathered in with my existing building. So you take advantage of a bigger footprint, and that's a good thing. Plaster and lath has a better sound quality than a typical framed wall. That's not always the case, and sometimes we have holes in them and things will, but in general, especially for your corridors, you've got hardy walls and they have a good sound rating. What are the cons? Number 1, environmental issues. lead-based paint, asbestos-containing materials, mold. You got environmental issues. You don't have to worry about it on new construction. Previous fire and smoke damage. Sometimes we'll find fire and smoke damage we didn't even know was there. It was a fire from 60 years ago. And we pull out the finish work and go, uh-oh. We had a building we worked on not that long ago in Upper West Side, and there was a fire on the second floor, and the fire went out into the light and air shaft, shot up the light and air shaft, hit the top of the building where there was a different flow, because now it's open to the elements, and went back in the 5th floor. So the 2nd floor and 5th floor were the worst damaged. 3 and 4 were not damaged, because the fire went right by it in the light and air shaft. The point being, we've seen fire and smoke damage that, you know, a fire department or a fire expert would tell you, oh, I can tell you the science of that. But you might not know until you start unraveling your building what you're looking at, what's behind the walls and ceilings. Not handicap accessible. Getting into the building, getting up the building, getting in the bathroom, kitchens, fixtures, everything not handicap accessible. That's a big con of a renovated building. Tenant relocation or tenant in place, very difficult. Relocating tenants is a big effort. Working with tenants in place is really difficult. If you want to work on a certain floor, the 3rd floor, you have to vacate the entire 3rd floor. That's hard. Okay, well, let's say you're just going to work in unit 3B. Well, you might need to get into 4B and 5B because you're doing riser work. So that logistics is very difficult, very challenging. And I feel for the tenants that have to be relocated. Some contractors stink at it. Some are okay. Some are very good. And what they'll usually do is they'll usually find some vacant unit somewhere, fix them up, and they'll checkerboard people. They'll move people from one place to another. They'll fix their units. They'll move people from here to here, and they'll just kind of move people back and forth. But the one thing I would say, the good GCs do 2 things well. Number one, they're upfront, honest, and communicate with the residents. They talk to them. They meet with them. They listen to them. They give them a phone number. They say, if there's anything that happens, let us know. And immediately the residents go, okay. And they become usually more of an ally. Number 2, they finish a unit or 2 and they say, this is what your apartment's going to look like. And the residents walk in and go, this is not bad. So you kind of can win them over a little. If you're a good contractor and you can show them, look, this is your finished product. And then all of a sudden they're going to start to work with you because they don't know who you are. I can see why they're concerned. But it's logistically, safety, timing, it's a challenge. Do much, much better with a vacant building than tenant in place. Another con, considerable structural work. Obviously, fire, smoke, water, notches, etc. And if you have a building, we've seen buildings that have been vacant for years and years and years. It's fine. It's fine. The moment that roof leaks, it's a house of cards. Because now water comes in, now birds come in, and now it's just a matter of time. So if you have a building that's had real disrepair or has been boarded up or abandoned for years or has been neglected, considerable structural work. Not cheap and takes time. Water damage, I think I've kind of covered that. Small bathrooms, I think I've covered that. Thermal inefficiency and lack of control. Thermal inefficiency means I'm losing a lot of heat in the winter and I'm losing a lot of cooling in the summer. Or lack of control. What's my thermostat? I open the window if I'm too hot. That's not very good. I need to do it if I'm too hot. But if you have this massively oversized boiler pumping out steam heat and it's just not that cold, people are opening the window. That's just dollars going out the door. So that's no control. You don't have a thermostat. It's not zonal. It's not an individual system. There's a lot of things we can do better today from an efficiency standpoint, and part of it is control. No elevator, obviously. And then historical or rent regulations. If you have people in that are difficult to move, even if you're going to fix up their unit, or if you have historical regulations, whether it's your facade, entire building or street, those are other considerations that with new, aside from the permitting process, we don't have to worry about. So that's it. That's a little bit of a snapshot. I was very excited to do this one because I thought I have not done this seminar in its entirety, and I added a lot of good photos recently to make it, I think, kind of more interesting to see how people used to live with ice boxes and dumbwaiters and things like that. So I thank you very much for watching. We do have a couple minutes. If anyone has any questions, if you want to go ahead and send on the chat, I'd be more than happy to answer them. Otherwise, I'll give you another minute or so. If not, thank you for watching. And next Wednesday, 1 o'clock, this is week 5, so we have 3 more weeks after this. Doesn't look like anyone has any questions. So thank you very much for watching. Be safe. Have a good day. And hopefully, oh, I got one question. Oh, you're welcome. Someone just said thank you. Be safe. Thank you for watching. And hopefully I'll see you next Wednesday.